Welcome, everybody. Hopefully, people are starting to get their audio settings set up and that you can hear my dulcet tones. And we're going to give a few minutes first for people to join us. Hopefully, you found yourself in the right place. So just bear with us and hopefully you can hear me. Yeah, we're expecting a few more attendees. And hopefully other people's laptops aren't telling them that it is far too hot. For those of you who know me, I hate these sort of awkward silences. Um, but bear with us. We'll just wait for people to join and set up the audio settings. By all means, keep your cameras off if you'd like to munch away on your lunch or for other reasons. But it is quite nice to see people's faces, and you're more than welcome to turn it on should you so wish, just so that both Freya and I are not speaking into the ether. But just bear with us. We'll just give it a couple of minutes. Hey, Tom. Let's see, Tom's happy to turn it on and eat. See, it's perfectly capable. This is all right. Hopefully others will be joining shortly. Thank you, Martin. So just bear with us. We'll give it one more minute and then we'll kick on. Hopefully people aren't melting too much where they are. Right, Nathan, on the basis that participant numbers will start to slow down in terms of joining, I am going to kick on if that's okay. So welcome everybody and thank you for joining us today. Just a bit of housekeeping. So the meeting is going to be recorded and will be available on our website in a week or so's time. Should also say that we have tended to put our these webinars through something called Accordion, which allows you to select the amount of time you have available. It's a bit of a clever algorithm and it condenses down the content into that. What we won't do is include the Q&A afterwards as part of that recording, so that will just be for today's session. I mentioned this only is should this be of use or should you find it helpful and informative, by all means, share the recording around when it becomes available, all that stuff. So if you experience any technical issues, then please raise your hand or you'll see there's an EWSC host, which is Nathan's pseudonym, it would appear. Nathan will be able to help out with any issues that you might have. Hopefully you can chuck that in the chat. We are going to be using the Q&A facility on Zoom, so there is a Q&A bit towards the end. Please try and put the questions related to the presentations in that, only that it allows me to try and monitor that whilst Freya's talking through the project. Otherwise, hopefully everyone else knows now how to use Zoom. I appreciate it's always fun navigating away through different technologies. Shall we go on? Right, so who are we going to hear from today? For those that don't know me, I'm George Warren, Anglian Water. I'm the Integrated Water Manager there. Also set up Enabling Water Smart Communities, which sadly, this is its final week, official week. As we're putting it, it's just the end of the beginning as we look to try and take things forward and through other means and maybe come up with a follow-on project. But there is a Water Smart Growth Board and Community of Practice, which we'll talk about later. I'm joined today by Freya Scott from Arup, who's a public health engineer there, who has been the brains behind much of the work that we've done here, along with ex-colleague now, sadly, in Eve, who won't be speaking necessarily, but will join us for the Q&A panel later. So Eve is now over at Thames 21, but previously was involved in helping to author this report. So that's who you'll be hearing from shortly. Next slide, please. So what are we going to run through? And apologies for those who have previously already been bored to death with me and my dulcet tones talking about enabling more smart communities. But I'm going to give, for those that are new to it, a brief introduction as to what EWSC is, and maybe just why we're doing this work on water reuse, and then hand over to Freya, who will go through the detailed report. The report is on our website, both an executive summary and a more technical report on the website that's freely available to download and access in a minute. But here is don't go straight to that. Freya will go through the kind of key headlines, and then I will then round it up with kind of what does this mean in reality before a Q&A session. So let's give a brief overview of the programme. Next slide, please. So what on earth is enabling more smart communities? Well, other than being a bit of a mouthful, it is an Ofwat innovation project all about trying to identify and then break down the barriers to integrated water management in new residential development. It has led by Anglian Water, but alongside United Utilities and Thames Water, heavily assisted by Arup as our principal delivery partner. And you'll see a number of different organisations there, including CIWEM, who are our comms and engagement lead for the programme. We have an independent programme board, which had its 14th and final meeting last week. This is where we bring together key stakeholders at senior levels to ensure that we're not reinventing the wheel, make us aware of any opportunities and become our champions, I guess, for the work that we're doing. It's been exceptionally helpful, and I would certainly recommend such a format for future projects too. Can I have the next slide, please? So what is a water smart community? Well, if honest, there's lots of potential definitions of it, but I would see it as a development or a local community where the residents are aware of and feel empowered to be part of that water system, looking at it in a more holistic manner. So not just seeing it as water comes in, water goes out, rainfall lands on the site. It's looking at how that water is managed throughout the course of its journey and feeling empowered to be able to do things on it, but both to help the environment and more widely the local community. Can we have the next slide, please? And I guess these are sort of some key elements that kind of come up throughout. This is a snapshot from actually one of our latest playbooks, which is just about to be published in the coming weeks, which helps to condense down some of the information on the basis that we have 161 outputs. So it's quite hard for people to see the wood from the trees. And therefore, trying to hone it down, we're doing a playbook for local planning authorities, one for developers, one for local community groups, and one for urban designers, so that you can quite clearly see what's coming out from it. Can I have the next slide, please? So in terms of sort of the barriers and enablers, we'll be looking into so skills, the stewardship and managing assets, the regulations associated with public attitude, and the costs, all of which we've done when it comes to water reuse. I wouldn't say fully completed because actually this is constantly changing. But we did do a piece of work previously around the capital costs associated with delivering water reuse at individual plot scale and community scale. This piece of work is then looking at the operational costs, the whole life cost, and the whole life carbon aspects of it. So hopefully you're in the right place. What's great here is that the public attitude is really positive towards such interventions. The regulations are still a bit of a barrier, but I'll get into that a bit later. But we're seeing positive movement in the right direction. On a skills piece, that is still a work in progress, but we kind of need a regulation to give us, and we'll start to aim for in a way. But work is being done on the skills side, and certainly further work on the adoption and stewardship of these is key. Have the next slide, please. So in terms of, I just briefly show we've done a lot of work, and this is just a snapshot of it, if honest, but you can see there's a lot of work on water reuse. So for those that aren't familiar with what we've been working on, please have a look at our website and you'll see a lot of stuff on there around water reuse and other aspects of integrated water management. So let's go on to the next. So why on earth are we doing this stuff on water reuse? Well, I did mention before that I was at Anglian Water, and I think it's important to just put it into context around our broader water resource management plan. So God, you can't go to one of these meetings without hearing about the jaws of death, despite it being almost a decade ago that Sir James Bevan referenced it. But we have a real issue when it comes to water resources. That won't be any news to most of you on the call. And so we had a real imbalance in terms of demands in comparison to resources available. Can I have the next slide, please? The way in which our WRMP has tried to balance that out is through a series of interventions. So we have a series of demand management options, some of which we're covering as part of this, but actually there's a large part around water reuse. So it is forming part of our plan for the coming years, both in terms of reuse in the form of turning non-potable into potable supplies, but also these more localized water reuse opportunities. We drastically need to reduce down the water demand associated with household and non-household means, and this is our route by which to amend it. And I wanted to put this in there just to show why it's important and what we're doing and how we're trying to provide a bit more clarity over how it sits in the wider picture. Can I have the next slide, please? And I think that's probably where I hand over to you, Freya, then, to take us through the work that you would have done on this, and I will put myself on mute.
Great. Thank you, George. Hi, everyone. I'm Freya, as George said, from Arup. And just to kind of clarify in case people aren't sure what public health engineer is, I do water and drainage design for buildings and kind of have done a lot of work on water efficiency and water reuse in buildings. And yeah, I'm going to talk about this project that we did for enabling water smart communities on the cost and carbon of water reuse. Before we get into that, I wanted to kind of give a bit of context so we're all on the same page on what water reuse is, and then we can kind of dig into the analysis a little bit more. So we've got lots of different types of water reuse options that we can design for buildings. Rainwater harvesting, grey water reuse, which is the water from your wash hand basins or showers, which is relatively clean. Then you've got mechanical systems, which you can use sometimes, which is like condensate from different mechanical systems. And then even black water recycling, which isn't as common in the UK, but is an opportunity you can look into. Then you've also got building scale. So that's how you can reuse within the same building, or you have a site-wide neighborhood scale system, which shares a tank and then supplies the non-potable demand across. It's really important to kind of assess which option you'll use for a specific site. There's different energy use and operational carbon things to think about, and the actual amount of water that you might be able to capture. So you always need to do a bit of an optioneering assessment. Another thing we have to think about is what wastewater can we use for what application. So the source, the quality of that water, and then the use is really important to look between. So in the UK, we don't typically treat reused water to a level where we would use it for potable consumption, but we would use it for WC flushing, irrigation, things like facade cleaning, washing machines. And in homes specifically, we'll use it for those purposes. So WC flushing, washing machines, and irrigation, external use. There's a potential in residential houses for about a 30% reduction in your water consumption if you are kind of looking at 110 litres per person per day. But this will be much more if you're actually using more water than this and you'll have a big flush volume, or you're using lots of water for irrigation. So that's kind of like a minimum that you probably would be able to save by implementing water reuse. Often in the building world and just in sustainability at the moment, we have this really big focus on carbon emissions and also cost, but it's really important for us to not just think about this and think about sustainability more holistically. Some frameworks like donor economics and the Sustainable Development Goals are really important and can help us think of how all of these different sustainability pressures can balance each other out, like biodiversity, flood resilience, water scarcity, things like that. Even more important for the water and property sector, because we have so much influence on each other. We have so many growth pressures at the moment for housing and also businesses, but there's constrained water resources and there's a bit of conflict, and we really need to have this systems thinking approach which can help us work together to solve some of these problems. So that's a little bit of kind of scene setting, and then now I'm going to talk about the analysis. So Arup undertook this assessment, and we had Siraj who was leading it, and then we had our civils and infrastructure team, then we had the buildings team, and we had a water team, and we all kind of did different tasks within this, which I'll go through in a little second. And our main question is, what is the whole life cost and carbon of different water reuse systems? And if we split that down, we want to carry out the operational and maintenance costs because, as George said, we've already done that CapEx assessment. So we want to see what the whole life kind of cost will be across the whole lifespan of a building, and then also the same for a whole life carbon assessment of different water reuse options. This is a really big problem in the building industry. A lot of people who are developing will say, well, how much is this going to cost throughout the whole lifespan? And there's not very much data on this at the moment, and especially carbon, we're learning so much and getting more and more data, but we need to have a little bit more information to give people for them to have more confidence in the designs that we're providing for them. So it's a really important piece of work, and I think it would really enable a lot more people to feel more comfortable with the solutions. So the methodology that we did, we went through sites that we were given. There was several different sites, which I'll talk about in a sec, and kind of defined the different parameters for them. Then we reviewed the bills of quantities for these sites. So there were all the materials that were included within the site. And then we undertook the cost analysis, which was a bit separate, and the carbon assessment. And I'm going to show you all the results for that. And then we did a bit of a comparison between those sites and the reuse types. So we got given about 12 sites, and they all had different characteristics. So it was a good way for us to compare how different sites might be more cost or carbon efficient for different water reuse systems. They included some low density sites. So these kind of typical housing developments where you have a garden and roads and things like that between. Then a mid-density site, so kind of low-rise apartment blocks or buildings, 1, 2, 3 or bedroom apartments. And then your really high density, so that's like student accommodation or these quite dense 1-bedroom or studio apartment blocks. And they might have communal kitchens as well, things like that. And the external area is quite limited on these compared to the other 2 density sites. We also decided to consider these different types of reuse options. We didn't include black water recycling or mechanical systems for this. And obviously you could combine some of these water reuse systems, but there's an infinite number of ways that you can recycle water. So we obviously had to stick to these ones. So we've got grey water reuse, which I spoke about earlier. So that's your wastewater from your showers and basins. Then we've got rainwater harvesting, and this is collecting from your roofs of your building, and it's also really clean. So it's quite easy to treat this. Then stormwater harvesting, we split this into 2. One of them is using nature-based solutions for the treatment. So you can use things like reed beds, and that takes out all the filters all the kind of stuff that you might get from roads and kind of more of the external things from the ground, because your roof has a bit more cleaner rainwater supply. And then we also compared that to the stormwater harvesting with more grey infrastructure, so a petrol interceptor rather than nature-based solutions, just as a bit of a comparison. Your typical boundary, which we would split this up to. So we've got the internal system, which is your green little box there. So that's the stuff inside a building, which is kind of what I do in my day-to-day job. Then you've got your external, which is the orange bit on the bottom. This is more kind of your civils or infrastructure type design. And then your water reuse, storage and plant. So this is what actually will store and treat your grey water or rainwater or whatever water you're capturing. And we split them into 3 different parts, so you could kind of add them together depending on your type of site afterwards. And just really wanted to point out that this is kind of a typical house on one of those low density sites, but if you've got a high rise, high density site, it really changes what proportions of system will be within that. So you've got a much smaller external system and a much bigger internal system here. So just kind of wanted to point that out before we go into some of the results, because it shows why different sites might have very different results. So the cost analysis. The operational cost, so as George said, we've already done the capital cost, which is the upfront cost, what you would pay for when you install the system. Your operational costs are your maintenance checks, so someone coming in to maybe check the filters or make some kind of adjustments, and your repairs as well. So there might be a leak or something that just happens over the lifetime of a piece of equipment or material. Then also replacement. All of our building services or mechanical systems will have lifespans, and then they're kind of due a replacement after that certain amount of time. You can obviously go in and check it and say, this pump is running completely fine, I don't need to replace it. Or you might just kind of fix something. But every piece of equipment does have a lifespan. And then there's also the labours for the work. So people coming in to actually do these maintenance pieces or get the replacements in, that's included in this cost assessment as well. So into some of the results. So firstly, we've got the external results. So not all of the sites, which I didn't mention before, had external and internal bills of quantity. So this is the ones that had external results for them. And you can see that site 10 has a really low cost associated with it. And that's because it was one of these quite high density sites that had loads of apartments in it. So per person, there's not much external stuff there. So it's not very expensive for it. Internal, we kind of zoomed in for the internal results as well to give a bit more of a picture of what it will look like between different housing sizes. So you've got 2-bed, 3-bed, 4-bed, and 5-bed here. And the cost is really reduced for higher density dwellings. And per person, a 5-bed is going to be cheaper than a 2-bed, but that's only if the 5-bed has 5 people in it, which you can kind of make an assumption for, but they will reduce per person. And then you've got your treatment as well, costs. So for this one, the operational costs for certain types of reuse are a bit higher. So rainwater and stormwater with the nature-based solutions were cheaper to maintain. So that's why you've got the reduced cost here. And we did this assessment for site 9, 10, and 11. And that's just showing a bit of a summary of this one. And then we combined them all for site 9, and so we could get an average. And this bar chart is showing what components were making up the external system per household per year, the internal cost per household per year, and the treatment cost. And the average was £174.50 per household per year. And we compared this to kind of an example service charge for a 3-bed apartment, which is about £2,700 per year. So if you take that into account, it doesn't seem too much, seems kind of reasonable. And I will also talk about this in a sec, but we were quite conservative with some of these costs, which I will talk about in a bit more depth in a sec. So when you take that average across all of the sites that we analysed, it's about £130 per year for a 1-bedroom and £220 for a 5-bed household. And then comparing that to water bills, you can really see that's where you're starting to actually save money, or potentially save money depending on how much your water bills are, especially with costs of water bills rising, or we're expecting that to happen. It could kind of lead to a cost saving in the future. And as I was saying, these cost estimates are really conservative because, as I was saying, all these building materials and pumps and things like that have a lifespan. You probably won't have to replace your copper pipes every 25 years, but it's just, we have to use a benchmark of what something is, and we use the CIBSE guides for this. But yeah, we were really conservative on this, and we are expecting kind of the maintenance works for people to actually go out and do these to reduce in the future, as water use becomes more widespread and commonly used as well. So next, I'm going to talk about the carbon assessment. So helpful to give a little bit more background on what a whole life carbon assessment actually includes. So this is your kind of system boundary of whole life carbon. Your stage A is your upfront carbon. So this is about your manufacturing, getting all the materials and then transporting it to the site. Then your in-use carbon, this is your replacement item. So what is it? When are you going to need to maintain it, repair it, replace it, or refurbish it? That's all what's included in there. Part of these in-use carbon emissions also are your B7 and B6 emissions, your operational energy and water, which are just at the bottom in that kind of brown box here. We didn't include them for this assessment, but yeah, they account for your energy usage and your water usage, but we didn't include them within the scope of this assessment. Then you've got your stage C, which is your end of life carbon. So that's when you're actually demolishing and transporting that and putting it to a waste disposal processing site. Again, I'm going to go through all of the results that we got. So external carbon, we did this across the site, so 3, 4, 6, 9, and 10 here. And you can see the average CO2 emissions per household here for these. Again, site 10 had the lowest, and that's because it's a higher density site. It has more households per kind of meter squared, so you're getting a lower cost here. And then internal, again, we zoomed into site 9. And we also split this up using one of our tools in Arab, one of our whole life carbon assessment tools per system. So those little colored blocks are all showing different types of system that you would include in your water reuse system pipework. So the pink is your wastewater pipe, for example, and then orange is your rainwater, and then the water supply pipe is the yellow, and then the green is the water supply accessories, and insulation is that kind of magenta one at the top. It's really important to note here that your rainwater pipework wouldn't necessarily be adding to your embodied carbon here, because you are going to have to drain your rainwater in a building regardless of if you have a rainwater harvesting system or not. So again, we're being quite conservative here, and same with your wastewater pipework. You don't necessarily need to double this pipework. You probably would have 2 drainage ducts anyway that would be taking the wastewater away. So there are definitely efficiencies here of the drainage pipework that we didn't include, just to give a bit of completeness, and you can kind of pull out some of these numbers to get what your system would have if you looked into the report a bit, so you can pull that out if you need that information. And then for the treatment carbon results, this is showing it for the grey water, rainwater, stormwater with the suds and the petrointerceptor. The stormwater with the petrointerceptor is much higher, and that's because this petrointerceptor is a really big kind of plastic container where the hydrocarbons and things like that will settle, and it just added loads of embodied carbon compared to the nature-based solutions, which we should all be doing because it gives you kind of all these other benefits as well. So yeah, nice to show that as a bit of a picture as well. And again, rainwater and stormwater, they need less stuff, so that's why they cost less, but also it means that they have less carbon, embodied carbon in them as well. And then combined, so for site 9, this is the average again. The average total is 1,994 kilograms of CO2 over a 100-year lifespan. That probably doesn't mean much to most people. It doesn't really mean that much to me either, because we normally will do this as an equivalent per meter squared, and that's how we sort of compare these carbon benchmarks often within the industry. Our study was over a 100-year lifespan because that's normally what you would kind of do for external systems, and we should really be pushing buildings to last for as long as possible to make them sustainable. But a typical reference study period for carbon is 60 years. So I've converted our kilograms of CO2e per meter squared into a 60-year one, which is about 9.25 kilograms of CO2 per meter squared. And then just to kind of give that some context, if we think about a heating and domestic hot water system for a house, that's 14.4 kilograms of CO2 per meter squared. And then for apartments, it's 26.1 kilograms of CO2 per meter squared. And that source is from the Future Homes Hub kind of benchmarking of carbon document. So a bit of a summary for the carbon. Again, so these really ranged from different types of apartments and the greater number of dwellings sharing a system, it really reduces the carbon. So you're getting scales of economy. So you're reducing the amount of carbon per household if you have a denser site. So it's really a better option, or can be a better option if you have these sites that can share systems really easily. And again, these are really conservative estimates because the lifespans that we're using are quite conservative. And also we did it over that 100-year lifespan. So if you might compare it to industry benchmarks, they might be using a 60-year lifespan. So just something to keep in mind there. We didn't include this in our actual whole life carbon assessment, but there can be kind of some of these carbon savings associated as well. So your B7 emissions, the emissions associated with supplying water and treating wastewater for buildings. So if I was doing this for a building that I would do a project on, I would look at the kind of carbon factor for the water company that's supplying my water and wastewater in the region. And then I would multiply that by the volume of water I'm using and the volume of wastewater I'm discharging from my site. And then that gives you these carbon factors from it. If we're reusing, we're offsetting some of our water consumption, and we're also reducing the amount of wastewater that we're discharging from our site. So that is reducing the carbon from the water companies in the region. So it's sort of a bit of a carbon saving. it depends on where your site is, how much impact that's going to make. These were just some kind of sources that we pulled from, but it really depends on if the water company is using recycled water, if there's desalination, that would be even more carbon intensive, or black water recycling, that kind of thing. So very strategy and location dependent, but definitely something to keep in mind, especially for the future, and kind of thinking about if it's beneficial to decentralize within this whole system, which I was talking about before. How can the water companies and the developers sort of work together to see what is actually the best water and carbon solution for that site? So just going to summarize now some of the key insights and findings that we had from the results. So water reuse is more affordable than assumed for the whole life operational costs. This is about 130 to 220 per household per year, but obviously depends on the type of site, the density, and what system you're actually using. And it's really important to do a full design of this and figure out what's actually happening on your site to see what is the best solution. And it will also, something that we didn't investigate in this, but about if you're refurbing and if it's a new build, there's a much bigger opportunity to be cost efficient in a new build than a refurbishment as well, which is something to think about. And we can also offset these further by environmental incentives, which water companies give for new residential buildings. So this is another EWS work stream. So there's a really good report standardizing the different environmental incentives that you can get. So this include water recycling, so rainwater and grey water, and other things like SUDs, but yeah, not within this kind of study. So yeah, definitely something to think about, reducing those costs more. And then the cost of water reuse can be comparable to some of these infrastructure upgrades. So things that a water company might be delivering within their region to deliver more water for a site, it could actually be cheaper to put water recycling within a site instead. So why are we not doing that? And then delivering wider benefits to that site in the future. Something to think about with that system thinking type of outlook again. Labour costs, these drive most of the operational costs. That was one of the biggest contributors to all of the operational costs across every single site. And really interesting to think about that. Would you really, maybe if you have someone, a building manager or facilities management team, will they be able to pick up some of these things as kind of their daily job? Is this something for us to upskill on and think about a bit more within the sector? How can we reduce these costs? Obviously, as water reuse becomes more widespread, the market will become more knowledgeable, and we expect that these costs will reduce as well. And then the carbon case could be positive. It could, over the lifespan, it's something to think about, and this will mainly be driven by the fact that a water company has a really high intensive carbon treatment that's required within that water resource catchment or zone. And I think I've already answered some of these questions, which I was supposed to wait till this slide. But yeah, the costs that we calculated were conservative, and it will become more affordable, especially as things develop in the future. And then the water reuse is comparable to these infrastructure upgrades. Labour costs expected to reduce, and then the carbon case can be positive. So I've been through those already. And then just to finish off, obviously that's loads of information to give you, and I've kind of tried to zoom in for the external, internal, and treatment systems into certain sites that will give you a good overview and comparison of them. But I would really recommend to read the non-technical executive summary report, which is on the EWSC project page. And then there's the technical report if you have a bit more time. And it goes through every single site. What was the results for each of these sites? And you can kind of start seeing a bit more of a story on student accommodation. It doesn't have any external infrastructure, costs and carbon associated. And it's got these kind of hallways that they share infrastructure for, so the cost is split per person and there's savings there. So lots of kind of nuances for different types of site, which are really interesting to review and think about for your different types of buildings.
That's great, Freya. Thank you so much. Geez, well, that was a whirlwind tour through quite a detailed piece of work. And thank you, Freya, for covering all the elements that I think you showed there, how it was a real team effort. So appreciate that not all of those elements were necessarily your fair hand. So please be kind with questions coming forward, as we may have to take some of them away to feedback to the team and come back to you. But so in terms of reuse, Can I have the next slide? One of the key things to come out whilst we were doing this piece of work was a publication from the Drinking Water Inspectorate and an expert group's recommendations. You'll see a number of those in here, which ultimately a greater clarity on the costs and operational costs associated with it will be really helpful. It may also lead, if their recommendations do come into fruition, and let's say the introduction, for instance, of maintenance and performance standards, that may well have a knock-on impact upon the indicative costings that we've produced here. We'd like to think that we've got this one covered in terms of what we've tried to estimate as the maintenance and inspection regimes, but it will undoubtedly, it may well have an impact. And there's other things in there as well around mandatory registration systems and the likes. So there's something to be mindful of. Ultimately, though, this is a real positive in terms of moving in the right direction here. We are, as a nation, very protective over the quality of our drinking water. We have world-class drinking water, despite what maybe some certain news streams might tell you. And we need to make sure that that is not impacted by the I guess, addition of an alternative, possibly lesser quality source of water within the building. And it's something that we are certainly not oblivious to, and will ensure as part of our works that it doesn't occur. But this is a real step in the right direction that the Drinking Water Inspectorate would like to see us push forward on this. We think it's necessary. We think it's still crazy that we flush toilets with world-class drinking water, but this can't be done without considering the risks. But there's some great stuff. If I go next slide, please. We are just in the process. In fact, we're just about to publish this piece of work, which is an update to our roadmap. I know it's the busiest image that you've seen today, and I'm not expecting you to take all this in. What you can see here, though, is with the number of things associated with our little logo, which may well look a little bit like Persimmon Homes ones, but I can assure you it's not the same. But we've delivered on a number of these actions, and the 10 red circles that you can see there are all the 10 recommendations that come out of that DWI report. So we tried to put this into a roadmap and show where we're trying to help address this. It gives you some sort of indication as to the length of time this might take to get to a real point of implementation, the work that needs to go on around this. But it is not so far down the line that we should be oblivious to it. This needs to form part of future WRMPs. This needs to form part of business cases for developments. And hopefully it gives you some indication of the sort of work that's gone on. I think if you press the next slide, just to show what that piece of work that we're talking about here today, that's the one I've circled there in gold. Okay, next slide, please. Fred did say, before that there are a number of wider benefits that we have not necessarily accounted for here in terms of costs. This is purely a costing exercise. We have not identified the benefits. It's not a cost-benefit analysis. There are a lot of benefits that can be derived from incorporating reuse schemes, and there are a number of those listed below. So, this is purely a costs, not necessarily identifying all the benefits. And hopefully you can see there that it may well stack up quite nicely as soon as you start incorporating some of those that we've listed down. Let's go to the next slide, please, Freya. We do have a bit of an issue in that we still have this wholesome water barrier at the minute. So in the Water Industry Act 1991, it states that all water suppliers should supply wholesome quality water for domestic purposes. Wholesome, supposedly equally potable. This is primary legislation and isn't easy to change, but there is certainly momentum gain here around amending it in some form to allow for such community scale reuse systems. there's an opportunity as well to potentially, assuming we can get over that, which I'm fairly positive that we shall, and certainly those sat within DEFRA and MHCLG seem to be supportive of it, of trying to amend changes. To see this actually come through in building regulations. One of the things that Enabling More Smart Communities is pushing for, amongst others, is the mandating of such systems for developments over a certain scale. We're suggesting over 100 properties or more, and that figure comes from our costings associated with capital costings. Others have done something similar. We think that mandating it and giving a lead-in time actually gives some clarity for the development industry, and also we need to be doing this. So we would like to see it in building regulations. In the absence of that, there is the ability for local plans to do such things and to mandate it within certain developments. Again, giving some clarity, but I think it needs to be done at a national scale to really help the development industry in that regard, because it makes it, otherwise it becomes a bit of a postcode lottery as to whether your development is requiring a reuse scheme or not. But there is a lot of work going on in terms of evidence-based to provide for local plans, but we would like to see it in building regulations ultimately. Can I have the next slide, please? So in terms of next steps, sorry, Freya, thanks a lot. Thank you. So I mentioned that we're in our final week of Enabling More Smart Communities, but it doesn't just end there. So we've set up a community of practice that CIWEM are operating, and the idea being that it kind of bridges that policy and practice thing, builds a community of change makers, enables learning and shared good practice, and drives the implementation of integrated water management and its impact. I would like to think that those of you who joined the call might be interested in potentially forming part of this community of practice. It will take forward the Enabling More Smart Communities assets, amongst others, will all form part of the website there, and it will likely to continue as EWSC. And it will be that one-stop shop for information such as ones that we shared today. Can I have the next slide, please? Now, this forms part of an overarching thing where we've created a Water Smart Growth Board. So this is a senior level growth board that has that communication with the task force at government level. This is supposed to be trying to bring the housing sector, the water sector together to have sensible conversations and trying to, I guess, overcome some of these barriers with government oversight. So it's jointly chaired by DEFRA and the Chief Executive Fagan, actually, and is the secretariat for that, is the Future Homes Hub. That community of practice feeds in. It's sort of almost the bottom-up information, with government sitting above the top down. Key, you'll notice there that the implementation groups, one of those four initial implementation groups will be on water reuse. And so there'll be more information coming out on this in the near future. The next slide, please. So I mentioned this community of practice. First of all, let's talk about the comms. There are two upcoming workshops associated. So there's an in-person workshop next Monday, I believe, and one later on in the week, which is online. So one's around sort of making communities central to Water Smart New Homes, and that's kind of how to engage. And then the second one is around that community-led stewardship. If either of those sound interesting to you, please get in touch. You can sign up via the QR code below. Can we have the next slide then? So I think we're going to go into Q&A. And I don't know if Eve has been able to join us, but if she has, then maybe she's able to turn on her camera. Otherwise, it will just be yourself and I, Fred. Hello, Eve. Good to see you again. I have just seen, right, I should have been monitoring this. I think Brian only just put it in there, or maybe it was whilst I was talking. So there is one in the Q&A. I would urge you to please Bob, you put your question in the chat. Could I ask you to put it over to the Q&A? Copy and paste, please. First from Brian McCarthy. Good to see you, Brian. George, can you confirm, as things stand, wholesome water, is it acceptable for a homeowner or community to run a water reuse system for themselves? Might not happen, but it does. Does it navigate current regulations? Uh, yes, is the answer. So the Water Industry Act relates to water supplies. What you do within your home comes under slightly different regulations. So if you were to capture it and manage it within your own individual building, that is possible. That's also potentially possible if you're in a community, if you're in a block of flats as well, as it's not the drinking water inspectorate are not the regulator for such things. It actually comes under local government regulation. Using and it's there. It's almost the different interpretations of the same regs. So you'll see lots of rainwater reuse, rainwater harvesting, and greywater reuse systems in tower blocks. They are still going ahead. Whereas you're not necessarily seeing the Eddingtons of this world, Eddington being development in northwest Cambridge, which has is a more dispersed development, which has a non-potable network, which unfortunately, up until now, has not been able to be turned on or supplied with non-potable water. There is a slight difference here that there is actually been a regulatory sandbox placed around it to enable them to actually operate that as a non-potable system, given its location, and that will be closely monitored as a result of that. So hopefully that answers your question, Brian. It can happen as a homeowner level. Our costing indicates that actually it is far more economical to be doing it at community scale, and is far more resilient in the sense of you're only able to capture what lands on your roof on an individual plot by plot basis, whereas it's across a multitude of buildings and services. Hopefully that answers it. Freya, did you want to, or Eve, anything that you want to add to that?
Yeah, just that I work in obviously buildings, and it's very common for us to do water reuse in lots of different buildings, commercial buildings, and also residential blocks that are sort of managed by someone. And it's about the management of that system, like who is responsible for it, more than the DWI things for this. So that's for the water supply that George and water companies would be doing. But yeah, if it's within your building and you own that, then you can manage it yourselves.
And we would certainly believe that there's greater, it needs to be a regulated side of it because of the potential impact of misconnections. And so, although that is the route by which it goes at the minute, and I appreciate that I might say this coming from a water company, but we think it makes sense to be managed by the water company in that regard. Thank you, Freya. Right, next one up. I should probably take Bob's note if I. So I'll take Bob's, even though it's in the chat, and then I'll come to Martin's if that's all right. So, so Bob Elliott says, "Thanks for a very informative presentation. How easy is it to get rainwater harvesting treatment from regulators for Clay Farm in Cambridge, especially DWI, in order to roll out this option at scale? How quickly can these schemes tackle water scarcity in the city to deliver sustainable housing growth? And can any lessons be applied to agriculture, including those through the community of practice? Why are carbon savings associated with water treatment and supply so much higher for angling water? And can the roadmap be shared?" Jeez, how many questions do you want to ask, Bob? So I think I sort of touched on it before around the regulatory sandbox that's been placed around Cambridge to enable the likes for Eddington to operate. Clay Farm actually is, because it's not a water company that is operating the Clay. So Clay Farm is another development, besides Addenbrooke's in Cambridge. It is not an adopted scheme. So Eddington, it was the network was to be operated by Cambridge Water. In Clay Farm, it's actually a private system, so it's not been adopted by a water company, and therefore it came under local government as the regulator, and has been operating now for several years. It's great to have that there because actually we can learn from that system as well, and it just happens to be in the same jurisdiction as Eddington. I think we can learn a lot from that, and I think that the drinking water inspector is certainly open to learning from that to ensure that we can try and maybe understand the risks a little bit better. In terms of just trying to amend some of these, so the roadmap will be shared, and it's just I think it's due to go out later on this week. It will be available on our website with an accompanying report just to explain what's gone on and what's changed in the interim time. I think the reuse certainly has to be part of the solution for tackling the water scarcity challenge within Cambridge. And in terms of the applications to agriculture, I see no reason why there are certain aspects that would be useful to translate to agriculture. But actually, I think it's a slightly different beast, to say the least. In terms of the higher water treatment supply in Anglian Water, that'll be down to density. So the amount at which the distance that we need to pump in comparison to, and the fact that I think it was the comparison was to Thames Water, and Thames Water have a far denser population. So it will be down to that. I don't think that we have over 1,000 sewage treatment works in comparison to Thames Water, who may have less than 100 on their books, and so it's that side of things which makes it slightly more carbon intensive. But I probably won't get into that right now, if that's all right. Right, I'm going to. So this one hopefully will be one for yourself, Eve and Freya. So, is there likely to be a difference in OPEX for new build and retrofit systems? And that's a question from Martin Osborne.
It's a good question, because the capex is obviously when you're installing it, and the OPEX will be, the OPEX is still a retrofit technically, because if you're doing the full install of a water recycling system on a retrofit, that's the bit that's costly, but that's sort of your capex for the retrofit. Hopefully this makes sense.
Yeah, so it should just be a very similar cost.
Yeah,
You may
yeah,
find that because of the retrofit, that actually it's not the perfectly designed system in
yeah,
terms of the routes of which it takes, or the location and access to the particular treatment plant. It hasn't been perfectly designed for the reuse system. That could be, that's for me, I imagine, the only reason that you might have a slightly different
yeah.
operational challenge.
Exactly. So it's like the capital bit that you'd have to do at the start would be different for the retrofit, and that might be more difficult because you might not have a big enough area to put your pipe through or something like this. But the bit where you're doing the OPEX of maintenance and things like that, it should be the same after that. Eve, I don't know if that's the same for kind of the infrastructure side.
Yeah, I would say the same for the external systems would apply.
And Martin, by all means, come in if you wanted to elaborate slightly more on your question, whether we've answered that. I can see you put your camera on.
I was just imagining there might be inefficiencies with poor access, takes longer to do maintenance and so on, but it's probably a difficult thing to investigate.
Yeah, and I think that's what we're alluding to in terms of not the perfectly designed system that could enable that, but on the basis of, if you were able to retrofit the system into the spaces that would ideally be suited to, then there should be no additional cost associated with it. But obviously, retrofitting into existing buildings and developments isn't always the easiest. But certainly the capital expenditure associated with retrofit is quite extortionate in comparison. Question here from Tom Arnott. So since October 2nd, 2023, collecting, reusing, and infiltrating rainwater will become the new norm in Flanders, Belgium. Is the EWSC network connected to Belgian colleagues, and are the lessons to learn from them? So actually, Tom, we haven't got huge connections into Flanders. The only route that we have at the minute is through the Water Reuse Europe group, and I probably bastardized their name there, through Marie Raffin, who chairs that, and through the UK Water Reuse Association, who are in constant conversation, I guess, with their counterparts across Europe. But we aren't directly linked. And so if, Tom, you have a suitable contact within Belgium who might be able to give us a little bit more information as to what's going on. We were aware of it, but we haven't necessarily had direct conversations yet. I think that would be a great thing to feed into the community of practice. So appreciate that.
Yeah, just a quick comment. I'd be very happy to make a link, both from the policy side and the implementation side from water utility. and we're bringing those relevant people across to the World Water Summit in Glasgow in October for a panel that Matt Wheeldon is running, and I'm sure you'll be aware of, in terms of rainwater capture and related stuff. But happy to broker linkages. They're extremely engaged and very happy to share their experiences, both from the policy development and implementation, and then how it's done in practice. You know, they've been going for 2 and a bit years now, so happy to do that. And by the way, congratulations on the project. I think of all of the Ofwat projects I've seen, you guys have led the pace with dissemination and sharing in a transparent way, you know, data and information. I think you should be congratulated on that. Well done. I think it's a very impressive project indeed.
Thank you, Tom. Thank you, and thank you for the offer to connect us up. And we're also running a workshop at the IWA Congress.
I know you are.
And possibly might look to align speakers and make sure that we can do this there. So really appreciate the kind comments as well. Hopefully this is just the start of the beginning. Sorry, the end of the beginning rather than the end of it entirely. Okay, in terms of other questions, Bob, please don't worry, you're not being troublesome. It's just me trying to cover this. Kat, is that a question there? Let's have a look. I'm say from Kat Moncrief from Cywin. Surprised that the whole life cost of water reuse is comparable or even more than supply infrastructure upgrades. You mentioned cost of maintenance. Are there other factors at play? Have you looked at how it compares to large new supply schemes such as reservoirs and desal? I don't know, Freya, whether you want to take that or whether you'd like me to.
I didn't do the kind of what the supply infrastructure upgrades cost were, so I don't know what that side as much, but I kind of would think it's about the cost per household type situation again, because if the reservoir is for like thousands and thousands of people, it might be to do with that. And the maintenance costs are a really big part of our whole life costs. And I do think that we were very conservative with the cost. I think if you would you say that for the kind of civil sides as well?
Yeah.
Yeah. So that's definitely at play. But yeah, George, I'll hand back to you for the kind of supply infrastructure upgrades.
I mean, actually, I probably see it as more of a positive, and maybe I'm misreading your comment here, Kat, and where you're expecting it to be significantly lower. Actually, I think we bear in mind that we're looking at current options, not necessarily the future options. Yes, we are building reservoirs right now, but the next options that we have available to us are desalinating the North Sea right now, and that is going to be both carbon intensive and costly. And so actually what we've done is compare it to the existing costs that we have to hand around cost per meter cubed of water. So the fact that it compares to current supply options, actually I see as quite a positive in this instance. I don't know, Kat, whether
Yeah, no, I expected it to be much lower, but I think if you're just looking at current costs rather than those big future water supply schemes, maybe that makes sense. And as Freya says, there's a lot of cost in there around the maintenance as well. Sorry for the tricky question. I could have
not at all. I'm mindful of time here. I'm not seeing any other questions. Hopefully I've addressed them, and that there isn't anything lingering in there that I've missed. We have 2 minutes remaining. I'm tempted to say give you all 2 minutes back and allow you to go and get a cold drink, probably, rather than tea or coffee right now before your undoubtedly next meetings. Unless there's anything burning that people wanted to raise, and if so, you chuck your hand up, please. I'm not seeing a hand, so let's can we just go to the? I don't think there is a next slide actually. I get Martin, is that a wave, a clap? I think it looks like clap to me, unless I've got this wrong. And thank you for the comment, Tom. Right, so I think it probably brings it for me to just close this. So thank you very much for those who gave up your time at this lunchtime. Hopefully you're not melting. too much. Sorry, I thought it'd just gone there. Hopefully you're not too warm there. Please, everybody, travel safely today. It's warm out there. And thank you so very much for joining this presentation. As I say, it will be available on our website in due course. And hopefully see you all very soon. Take care.